Hello, I am Lakshmi Dikshita. I am here to explain my topic. The topic is to find my maximum and minimum value. And I am from Computer Science Department. I am here to explain my topic. My topic is to find maximum and minimum value. Maximum and minimum value of f of x comma y equals to sin x plus sin y plus sin of x plus y. Introduction to the function. The function we will analyze is f of x comma y that equals to sin of x plus sin of y plus sin of x plus y. The function is a combination of sine functions which are periodic and bounded. Understanding the behavior of this function will help us to determine its maximum and minimum values. Properties of sine function. The sine function oscillates between -1 and 1 for any real input. Therefore, each term in f of x comma y is bounded between -1 and 1. This property implies that the overall function f of x comma y will also have specific bounds. Range of the function. To find the minimum and maximum values, we first determine the possible range of f of x comma y. The maximum value can be approached when each sine term is at its upper limit of 1. Consequently, the theoretically maximum value of f of x comma y is 3 and the minimum value is -3. Consequently, the theoretically maximum value of f of x comma y is 3 plus 3, that is positive, and minimum value is -3, that is negative. Finding critical points. To find the maximum and minimum values, we compute the partial derivatives of f of x comma y. Setting the partial derivatives equal to 0 will help us to locate critical points. Setting the partial derivatives equals to 0 will help us to locate critical points. The critical points are essential for identifying local maxima and minima in the function. Solving the system of equations. The critical points can be found by solving the equations dou f by dou x equals to 0 and dou f by dou y equals to 0. That is, I repeat, dou f by dou x equals to 0 and dou f by dou y equals to 0. This leads to a system of equations that can be complex yet solvable. Evaluating these points will reveal the possible locations of maximum and minimum values. Evaluating the critical points. After identifying the critical points, we need to evaluate f of x comma y at these locations. After identifying the critical points, we need to evaluate f of x comma y at these locations. This will involve subtracting the coordinates of critical points back into the function. Comparison of these values will allow us to identify the global maximum and global minimum. Comparison of these values will allow us to identify the global maximum and global minimum. Boundary behavior. In addition to critical points, we must also consider the behavior of f of x comma y at the boundaries of the domain. In addition to the critical points, we must also consider the behavior of f of x comma y at the boundaries of a domain. Since sine functions are periodic, examining specific intervals can reveal additional extrema. Since sine functions are periodic, examining the specific intervals can reveal additional extrema. Thus, evaluating f of x comma y at boundaries provides a complete analysis of its behavior. Conclusion and summary. The maximum value of f of x comma y can be found to be 3, while the minimum value is -3. The maximum value of f of x comma y can be found 3, while the minimum value is -3, which is negative and positive. Both positive and negative values are here. When the maximum value of f of x comma y can be found to be +3, this positive axis, and while the minimum value is -3, which is negative. Understanding the periodic nature of sine functions is crucial for analyzing f of x comma y. Understanding the periodic nature of sine functions is crucial for analyzing f of x comma y. This analysis showcases the importance of critical points and boundary behavior and optimization. Thank you.